Well, good afternoon. It's a great pleasure to welcome Professor Gennaioli, full professor of finance at Bocconi University. Thank you, Nicola, for participating in the 44th edition of the Barcelona School of Economics lecture series. I would also like to welcome Jordi Brands and all of you, Teresa, members of the Academy in Barcelona, students, ladies and gentlemen, this afternoon here at the Col·legi d'Economistes de Catalunya. In a moment, I will hand you over to Jordi, who will introduce Professor Gennaioli. Before, I would like to say a couple of words about the topic of today's lecture, which is especially relevant in the environment we live in, that is quickly redefining the nature and functioning of our society. As we witness how new drivers such as weather change, new geopolitical conflicts, post-truth, or artificial intelligence are reshaping the world economy, traditional models no longer provide us with the tools we need to reflect on economic agents' behavior. Now we know that issues such as the certainty with which we look to the future, the way we relate to each other, and the rationality of our decision reveal themselves as the hidden drivers of economic and social patterns. As economists, it's not simply a matter of trying to guess the probability of occurrence of new events, but of understanding the channels through which these events can further reshape the environment around us. That is why it's a privilege to have today among us Professor Gennaioli, expert in developing psychologically founded models of behavior and applying them in fields like finance, macroeconomics, or politics. So thank you very much again, Nicola, for being here, and Jordi, the floor is yours.
Okay, thanks. So it's a great pleasure to introduce Nicola here at this lecture of the Barcelona School. I will say very few things. Nicola has an undergrad degree from Bocconi and a PhD from Harvard University. He's currently a professor of finance at Bocconi. Before that, he worked at the IIES in Stockholm and also was a senior researcher at CREI and a research professor of the BSE, so it's a little bit like coming back home. He has had all the ERC grants and published in all the major journals, and basically everything he does is great. So you will see this now in a second. His research focuses on psychology and economics and consists both in developing psychologically founded models of behavior, in testing these models and applying to various domains. And that's all I have to say. And today his talk is about beliefs in economics, which I guess is a subset of psychological issues, evidence, and some theory. So please, Nicola.
Okay, thanks for the kind introduction and for the invitation. It's magnificent for me to be here. You know, I feel this is like my second home. Today, I will talk about salience and memory quite a lot. And I have to say that, you know, I just feel there's so many great, beautiful, salient memory of my time in Barcelona working with, you know, people here in the audience and living in the city that, you know, again, great to be here. Thank you again. I will give an overview of some work that has been done recently, you know, part by me and co-authors, part by others, on beliefs in economics and buttressing kind of the importance, in my view, of this research for thinking about important economic topics in a new way. So what are beliefs? Beliefs, we generally refer to them as opinions that are not necessarily mathematical proofs or the result of physics experiments. They are more uncertain pieces of knowledge. They can be about the future state of the economy, the value of a consumer good, the competence of a job applicant, etc. Many, many things. And the key of beliefs is that typically they've been neglected by economists. How? If you think about microeconomics, it's about measuring choices, and then from choices inferring preferences that are stable parameters. of our models and analysis. If you think about macro and finance, there are beliefs that change with news, but beliefs are pinned in equilibrium through the rational expectations assumptions. In the last decade or so, there has been this growing effort of actually go out in the world and measure beliefs, okay? And see what they look like and see whether they can help explain decisions. And the set of findings of this work is that first, belief exhibit some systematic error, and second, these errors help explain market phenomena and economic behavior. So the structure of the talk is that I will overview some of the salient findings of this literature, and I want to emphasize two aspects. The beliefs that we see in the data exhibit what I call instability. Instability means that they tend to depend on features that are not necessarily so relevant, or they exaggerate the importance of these features. And the second aspect that's important of the measured beliefs is the vast heterogeneity. You can take, the simplest macroeconomic variable, for instance, about which, we probably have a lot of information, etc. And it's just one outcome that we should all forecast, and you see a very large dispersion. And I will argue that these features of beliefs are a challenge for both the neoclassical and the behavioral approach. They suggest that one should go further into understanding the psychology of beliefs, and I will propose two elements for starting to think about it. One is selective attention, the other is selective memory, and I will discuss some of the implications. So I first want to show you some empirical findings from macrofinance, labor, political economy, and consumer choice. But of course, the domains to which measurement of beliefs has been applied is wider. One, take the standard finance textbook model of asset pricing. The price of an asset is the present discounted value of rationally expected future dividends. So beliefs are kind of here, and then there's a constant discount rate. Now, in the 80s, Schiller argued that's not a good model because dividends are just way too stable. So if you have rational expectations about them, that would not lead you far into explaining stock price volatility. So he made this argument by computing a proxy for the price using future foresight of dividends and fixing the discount rate R at an historically reasonable value. Now, in recent work with Bordalo, Schleifer, and Laporta, we reproduced Schiller's exercise for the post-81 period, but then we also take expectations data, analyst forecasts of earnings growth of individual stocks listed in the US, we aggregate it up to the S&P 500, and then we fit, rather than the realized dividend, the believed earnings for the future. So this is Schiller's exercise in the post-81 period. The blue curve is the perfect foresight price. The green curve is the actual price, excess volatility, okay? The actual price fluctuates a lot. And then, the classical approach in finance has been to say, oh, maybe here people were not so risk averse. That's why the stock price was high. And then here instead people were very risk averse, like changing preferences. But what happens if you keep the rate of return, the discount rate constant, and you just fit in the expectations that you measure in the survey data? That's the type of price that you get. The fit is not perfect, but you get a lot of the volatility of the actual price if you simply put beliefs into the formula. Now, it turns out that these beliefs are very useful, not just to kind of keep track of the price level and its fluctuations, but also to think about, the rationality of this belief. So when you see that analysts are optimistic about the earnings growth of their companies that they follow, you see that systematically, subsequently, they are disappointed. So they make predictable forecast errors. So there is an excess volatility in beliefs that then can explain excess volatility in asset prices. The other thing that you see is that when you see this belief optimism, that predicts low stock returns in the future, which means that beliefs can unlock a road to understand market inefficiency and predictability of future stock return. That has been a major puzzle in the finance literature. And recently, we have explored, and there is a paper in preparation for the NBR Macro Annual, the connection of these beliefs of future earnings growth to macroeconomic variable, and in particular here to investment. You know, expectation of future earning growth is high. It's time it's productive to invest, and so you could get an investment boom, but perhaps excessive because we are too optimistic. And if you try to predict future investment to capital using this measure of analyst optimism, you see that it predicts a boom up to 4 quarters out and then a reversal. Okay? So there are very standard, very basic microfinance issues that, you know, can be informed by the use of beliefs data. Belief heterogeneity, the previous facts were about instability. Beliefs move too much and move the market up and down. Heterogeneity, we know from Malmendier and Nagel that things like the experiences we had in our own life with the stock market influence the return for the aggregate market we expect for the future. So that's a source of heterogeneity, which is, however, you know, much more widespread than cohort effect and any type of data set. And here I'm quoting some other work, you know, like documents. So why do we come to have different views and why our beliefs are so unstable? Second set of issues, beliefs in labor and political economy. Here beliefs are about social groups. What's the standard approach to beliefs about social group? That, you know, taste-based discrimination or statistical discrimination, in which beliefs are on average correct. Now, measurement of beliefs, what reveals is that there are systematic stereotypes, misconceptions about social groups. And these misconceptions take two forms. One is the discrepancy between the outcome that we believe about people or ourselves and the true outcomes. And the other is a discrepancy between first and second order beliefs, a discrepancy between what we believe other people think and what other people actually think, belonging to different social groups. And stereotypes, this misperception, as I will show, have a structure to them. It's not that these are random errors. You tend, when you form stereotypes, or when you look at these social beliefs, to think about people from a group exaggerating their distinctive features relative to outcomes. So there is a structure to errors, and that's an important point. There is, of course, a lot of work in political economy with the rise of populism, the erroneous beliefs that people have with respect to, you know, science, with respect to also the features of immigrants, etc. It's a very large literature. Here I'm going to distill just a few key findings. So let me go to the first type of phenomenon, stereotyping about facts, okay? The social contamination of beliefs. Here I'm showing research from 2019 with Katie Kaufman and Pedro and Andre. And here we want to ask how people are confident in their own ability in certain domains of knowledge. So we ask people to solve questions in math, in literature. We have 12 subjects. And then we ask them also to state how confident they are in the answer they gave. What's the probability they think the answer is correct? And here on the x-axis, I have the true hit rate of these people, the share of correct answers they give. And on the y-axis, what you can see is the belief that people have of having hit the right answer to the question, okay? The red dots here are females, the blue dot are male. And what this graph shows is that if you are in a triangle, okay, this is a male stereotype activity, it's math. If you are in a circle, that's a female stereotype activity. It's, say, literature. The social feature affect how people are self-confident. For a given ability here, for a given true hit rate, you know, the same person, the same woman can be underconfident in math and overconfident in literature. So again, what this points to is an instability, and here it comes that is not that you are either confident, overconfident, or underconfident, but it's a feature that you attach to specific domains by bringing differences with people that are from different social groups. You exaggerate those differences. This is instead about second-order beliefs. This is a paper by Leo Burstein and a set of co-authors. This is about the opinions that people have about others. They do a large survey in 60 countries, and what they show is that the perceived female-man gap in support for women's rights and affirmative action exaggerate the true actual gap. So people tend to think that, you know, women are much more in favor of gender equality than men, then it is actually the case. And that's how they document it. This is the true gap. And this is what male respondent believe and female respondent believe. On the y-axis, the actual gap is. Above the 45-degree line, there is exaggeration. With Katie, again, we did this analysis in 2016, okay, about politics, because you can ask the same thing about politics. Suppose you take conservatives and liberals, and there is a lot of survey data on what I think a conservative believes or what I think a liberal believes. And you can compute a measure of believed disagreement with the actual disagreement on a variety of issues, you know, abortion, gun control, etc. If you plot actual disagreement to belief disagreement, again, you see exaggeration above the 45-degree line. Again, beliefs capture part of the truth, okay? They capture the fact that conservatives are more conservatives than liberal, but they exaggerate relative to reality. There is an instability there. There is too much social features are fed into the beliefs. So these beliefs have this exaggerated reaction to differences, heterogeneity across people having different backgrounds, and this is a challenge to rationality because it's not like in this statistical discrimination approach in which beliefs reflect reality. Now, another domain, recently it has affected all of us. You know, COVID in 2020, we had this unprecedented shock, and we should form opinion and decide what to do upon its occurrence. There's been a lot of work done, you know, looking at how opinions about COVID affected behavior, and there's a large literature on that. Here we wanted to ask, where do the beliefs about COVID come from? And one thing that we ask respondents is, what do you think is the chance that you die if you get COVID? The conditional, you know, infection or fatality rate of a person for him or herself. We ran a large survey in the spring of 2020, and this is one of the findings we had. These are people between 18 and 30 years old. These are people above 69 years old. Okay, people between 18 and 30 years old believe that if they get COVID, they die with 7.5% probability. 75 is out of a scale of 1,000. Okay? This is a vast exaggeration relative to the true infection fatality rate. If you take people above 69 years old in the very same period, they believe they would die with something like 4% probability, compared instead to a true infection fatality rate of about 5%. Massive heterogeneity, there is no universal distortion, overestimation of rare event or underestimation. The young overestimate, the elderly underestimate, and they actually invert the gradient relative to reality. So heterogeneity is really important, and we've got to explain where this is coming from. We also asked what people think about the average US resident. What do you think is the infection fatality rate for this person? And one thing we found very surprising to us, again to testify the nature of the instability of beliefs, how they depend on features that are very subtle and little relevant, is that people, those who had a family member hospitalized for non-COVID reasons in the past, they are significantly more pessimistic than others. Not for themselves, not for their family members, but for the average US resident, okay? Which is, again, maybe these people are like using the conditions in their family to project bad health into others. It's easy for them to think about that. But again, you know, it shows this instability. And this is the difference at the same time between people who had COVID and survived and people who didn't have COVID. People who had COVID much more pessimistic than people who didn't, even though they didn't die because of the virus. Again, maybe this was salient in their head, maybe, but there is something that affects beliefs that we do not fully understand and generates this instability. I want to conclude this initial illustration with two examples for consumer choice. The first example is, you know, a famous paper by Lune, Chetty, and Croft from 2009. What they show, they document that if people are asked to estimate how much they spend in grocery, they underestimate the final expense because they don't take into account sales taxes, which are paid at the counter. But if you remind people of sales taxes, people cut their spending. So the same piece of information that they have in their mind, the taxes which they know exist, is not brought to the front when making the decision to purchase. Again, this is instability. It's like an aspect that is transient, the display of the tax or not, that affects the way you value a good. And then there is this paper by Busse, Pope, and Risso, in which they document with extremely detailed data that consumers who buy a car are more likely to buy a convertible car if they test drive it during a sunny day, in which the temperature is abnormal relative to the seasonal average. And even if they owned a convertible before, so these guys are not really learning much. And you see, these are the temperature, the effect of temperature on the probability of buying a convertible. Again, there is instability. There is a totally transient aspect, which is the weather on the moment you make the choice that has an influence on the type of decision that you make. So taking stocks, if you go out, measure beliefs, and relate them to action, you see that what emerges is that people tend to display this instability. Sometimes the features are a bit informative, like the earnings news, but there is too much of a reaction to it, like in the case of the stock analyst. Sometimes the features are utterly uninformative, you know, the weather on the day you buy a car, but that is something, or whether a tax is displayed or not, but that still affects what we believe and what we choose. And then there is this strong heterogeneity. These type of facts challenge not only the standard rational approach, but also some proposed solutions to it or amendments of it, like rational inattention, in that setting, you stay anchored to your prior, you don't display this strong instability on the basis of momentary aspects. Another approach, which is like in situations devoid of regularities of statistics, that was developed in computer science by Schenck in the 80s and then brought into economics by Gilboa and Schmeidler, is the idea of case-based reasoning. You have a problem and you make an analogy with a problem you've encountered before. But this does not explain why, if there are data statistics, you don't use it, or why you may use not the most relevant problem in order to understand the current situation, but something pretty flighty and momentary. The trouble, I argue, with these approaches is that they assume that the fundamental assumption is that when people make decisions, they bring to mind only the relevant stuff, or they focus only on the most relevant experience they have. There is no kind of uncertainty or friction or problem in what people are thinking about, in the information they sample from their memory, or the information that they search, they look at in the environment. But this, I argue, it's also a problem for behavioral economics. First of all, behavioral economics are mostly studied, not beliefs, but departures from rational preferences that have to do with the curvature of the utility function, the discount rate, etc. But also that behavioral economics typically proceeds by making specific distortions to base rule. But what we see is a richness of distortion. So if you want to use this approach, you have to have many different heuristics, many different distortions in different settings. And so you're not going to achieve unity. You lack parsimony in this approach. What are the foundation for the large dispersion and the instability? Why relevant features matter and different people have such different beliefs? Some overreacting to their event, some underreacting. So the major challenge is to build a unified framework here. Now, in 2010, we were actually working on the board of CREI, of the CREI seminar room with Andrei. I still remember this time. We wrote this paper, which then led to the development of what later has been called the diagnostic expectations model, which is based on intuition about selective memory, and in which the distorted belief about an event omega in light of data D is the true belief and a distortion term that depends on the increase in the likelihood of omega in light of the data D. Okay? Now, it turns out that if you take this model, there are several aspects like stereotyping, etc., of the data or overreaction of macroeconomic forecasters that you can fit, but we were not very happy with this model, okay? And the reason we were not happy with this model connect to what I was talking about before. First of all, these models relative to standard behavioral model give you that irrelevant features may matter, you get instability, because you evaluate relative to this reference distribution. But where does this come from? What's the foundation for it? Here we had this idea to kind of include this into our model by reading Kahneman and Tversky work, but that's not based on cognitive foundations. The second aspect is, how is the relevant distribution, the true distribution, sampled? I mean, it's not that people have the true distribution on the one hand and like an irrelevant distribution and they combine the two. They're not thinking about it. It's like a representation that has to emerge out of a process. What's that process? And also what the role of individual experience is here. So in the last 3 years, this was partly due to the madness of COVID. We decided to try and give it a shot and, tackle this issue building a framework in which you can derive this property, but based on cognitive factors, and we emphasize two cognitive factors. One is selective attention. Selective attention is which features in the environment you focus on to represent a problem. So suppose you are in the stock market, you see a company, you could think about the past price growth, you could think about the earnings growth, the fundamentals, you could think about the sector the company belongs to, or you could think about Elon Musk's tweet, you know, and that's a feature that may attract your attention, and you may build your representation on it. It's out there, available. So selective attention is the first step. The second step is selective memory. That conditional on the representation, you retrieve things. So if you think about a company in light of Elon Musk tweet that you know, Tesla is a consumer software firm, maybe you think about Google. You don't think about a car producer, okay? If you sample memory by thinking about earnings growth, then you will sample something different. So the two things, attention and memory, get combined. And it turns out that in this approach, you can get heterogeneity and instability by putting signs on the type of attention and memory effect that have been documented in psychology. These are very old regularities, you know, for almost 100 years. People have assembled regularities on what drives attention, and in particular, they attend to salient features, which are not necessarily the most relevant ones, but there are those that are contrasting, surprising, and prominent. So if you test drive your car and it's sunny, weather is a salient feature. And so thinking about how you drive this car in a nice weather is very immediate. That's a salient feature. Memory is that people retrieve experiences on the basis of available cues, but they don't retrieve experiences perfectly. They retrieve them based on similarity. So if you drive under nice weather, you retrieve similar moments in the past in which you were driving under a nice weather. And you say, how nice it is to drive a convertible. That's why even if you had a convertible before, you're happy to buy it again, because you sample selectively. You don't sample everything. Or that's why if you see a good with a price tag that excludes the VAT tax, you think about the price tag. You don't think about the VAT tax. You think about price tags in other shops, but you don't think about the VAT tax. That's not salient. So the type of experiences you retrieve is selected. And then, of course, frequency and interference are other important regularities. So what I want to show then, like I will not do equations today. I've already did my job with diagnostic expectations. But I want to illustrate with two abstract experiments how we think about attention and memory, okay? And what they can bring to the table, the type of structure that they bring to the table. So first, consider the role of attention for beliefs. Here, we do an experiment in which we describe everything. And then you have to answer a probabilistic question. You have to estimate the probability of an event. There's nothing to remember here. Here is the type of information you weight, you consider. This is a famous inference problem. It's called balls and urns. Urn A contains 80% green and 20% blue balls. Urn B contains 20% green and 80% blue balls. A computer selects urn A versus B with probability 25 versus 75%, and then draws a ball from it. The ball is green. What is the probability that it was drawn from A? Very canonical problem. There is a prior, 25, 75, and then there is a signal that has 80% accuracy. Okay? If you use Bayes' rule, you find the answer. Lots of controversy about this. for the last 50 years. You know, Edwards was a psychologist, one of the first doing this experiment, and say, you know, people underreact because the average answer was too close to the prior. Then Kahneman and Tversky came and they said, no, people overreact because in other formulation, people stay further away from the prior more than the Bayesian guy would do. Then consider this version of the same problem, which is actually due to Kahneman and Tversky themselves. It's called taxi cabs. There are two cab companies, green and blue, by the color of their cabs. 25% of cabs are green, 75% are blue. A cab was involved in a hit-and-run accident, and a witness reported its color to be green. A test reveals that the witness can correctly identify the color of each cab with probability 80%. What is the probability that the cab is green? Same question. There is a prior, 25, 75, and there is a likelihood, 80% accuracy of the green witness statement. You can do the math, it is the same. Okay? Now, what I'm going to show you that it's kind of remarkable to us, that was not studied before, is not the mean answer, the modal answer, but the distribution of answers in these problems. Consider balls and urns. This is the distribution. That's something you cannot summarize with one statistic. It's not that people overreact or people underreact. People essentially locate, the correct answer is the dashed line. People, and the mean answer is the solid one. People essentially locate around the three modes. One, there are people who completely neglect the color of the ball. They just don't pay any attention to it. And they say, I know that an urn is selected with 25% probability, I say 25%. Then there are people who don't think about selection at all. They say, oh, it's a green ball, it's similar to urn A with 80% probability, because urn A is 80% green. So they assess sort of the similarity of the ball to the urn, and they neglect the selection, and they report the full likelihood. It's not that there is a debate, do people under or overreact? You know, some people overreact and some people underreact. And then there are people in the middle who say, oh, I have no clue, you know? It could be either one or the other. It's 50%. So there is heterogeneity here, wild heterogeneity in a problem that has an unambiguous answer. Okay? What happens if I go to cabs? You could think, well, these are different types. There are some underreactors, some overreactors, and now I can have my nice economic models with a distribution of types. That's what happens when you go to taxi cabs. It's like the model of the problem changes dramatically. Now, there is a huge incidence of people who just focus on what the witness says, and that's not coincidental, because when you are in a court of law, what do you pay attention to? You pay attention to what the witness says and the accuracy of the witness. If the witness statement is correct 80%, you say 80%. Just the representation of the problem changes because of a totally irrelevant rewarding, and that's the instability. Now you could say, well, Nicola, you told us a nice story, but you know, how can I see that there's an attention mechanism? Well, you can go out and you can measure attention. So we asked people what they attended to when solving the problem. We also had them write a text, and we had the ChatGPT analyze their text. They could attend to selection of the urn, the color of the ball, the similarity between the signal and the urn, other features, or none. Here we regress the probability of ending up at the prior, the likelihood, the Bayes correct solution, or 50-50, based on attention to different features. People on the Bayes rate attend only to the urn, to the selection. People on the likelihood attend only to the signal, and the other attention profiles load negatively on it. People on Bayes pay attention to both features jointly. That's why applying Bayes' rule is so difficult, because you need to think about both features. And people who reply 50-50, they basically don't attend too much. Treatment effect, as you move to cabs, large shift in attention, reduction in the attention to earn selection, strong increase in attention to the similarity between the earn and the ball, or the witness statement and the cab company. So you can see how attention here is central. Description, no ambiguity, sharply different representation, but instability with switches in attention across features. The role of memory, yes? No, this is across subjects tests. Yeah. No, but you see a shift in the distribution, which means that presumably the two samples are drawn from a similar population. Of course they are, I mean, it's the same pool of people, and you don't see a stability of the distribution. Yeah, that's fine, yes, which is irrelevant, which is normatively irrelevant, which means that. Okay, the role of memory and attention, moves. The role of memory. Now we do experiences. You go through an experience, then there is a delay, and then I ask you a question about the experience. So now you have to remember. We show subjects a random sequence of 40 images, words and numbers. And 20 images are orange, 20 images are blue. Treatment 1, all blue images are numbers. Treatment 2, all blue images are words. What is the question? A randomly drawn image is orange. What's the probability is a word? So it's about the conditional distribution among orange images. Blue is irrelevant here. Okay? Of course, they are experienced, the blue. So the question we ask is, do belief depend on recall of experience images? And are recall and beliefs affected by this irrelevant feature? Again, irrelevance, instability. The blue images, even though I have to assess the orange. This is the belief distribution. The correct answer is 50-50. Okay? This is the case in which you have no blue images. People get it correct on average. Here people overreact to orange, overestimate the number of words. Here they underreact to orange. They underestimate the number of orange words. This is a treatment in which all blue images are numbers. You kind of overestimate the distinctive type, the word, because the blue, it's numbers. And here you do the reverse. Here, blue images are all words. So you overestimate, again, the distinctive type, or underestimate the common type. In this case, the words that are both orange and blue. If you look at recall, we ask people to recall the words, orange words, that they saw. And what you see is precisely a memorability effect. When all blue images are numbers, people are good at recalling the orange words. But when blue images are words, people are bad at recalling the orange words because they get confused. They recall some words and these presumably are blue. And so there is interference in recall. There is something irrelevant that affects what comes to mind in your belief. And you can actually show analytically that this type of memory interference gives you exactly the type of diagnostic distribution, the exaggeration of stereotypes. Memory and heterogeneity. See 40 images, 20% are animals, 80% are names. and ask, first, an image is drawn, what is the probability it is an animal? 2, recall the images you saw, okay? So here is pure beliefs and memory. This is the belief that a random word is an animal, and this is the actual animal recalled over the total words recalled. Strong heterogeneity based on selective retrieval. People who remember many animal words, maybe because they attended to them, they estimate the number of animals, which is always the same, 20% higher than people who recall fewer animals out of the images they saw. See, experience is not mechanical. It's not we experience something and that's forever. You have to recall things. And cues, what happens around you, it's important. You know, the weather thing. So growing evidence challenges stable revealed preferences and rational belief, and you see it in the field when you measure beliefs of people. You see it explains actions, and you see that excess volatility. Does this mean we open Pandora's box that anything goes? No, there is a motivation to write models that captures important phenomena in cognitions that are selective memory and attention. You know, realistic models that put structure based on things that you can measure. You can measure attention, increasingly so, nowadays, okay, with a lot of online surfing, you can do that. You can measure memory in surveys. You can measure experiences also in surveys. So that's something that is achievable. New implication, let me illustrate one example of this work. Zhang, Liu Peng, and Yang, they have a recent paper in which they ran a large survey of Chinese investors. And they ask investors to report expectations of stock returns for themselves and for the market. But I will only report those for themselves today. And second, they ask investors to recall what actual return they made in the past, in the last month. And the key thing of this survey is that they measure what the actual return of the investor is because they have investment data. And then what this author study is how recall returns depend on your own experience return and the current market return. And B, they study how your expected return for yourself in the future depends on memory. First result, I find this quite striking, okay? If you ask an investor to recall what return he made in the last month, the own return is positive and significant, makes sense. Higher experience return, higher recalled return. But the current return of the market is also positive and significant, which means these people are in high markets. It's like driving a convertible in good weather. And that cues them to recall good returns they made in the past. So you see, it's not just a mechanical experience. There is information brought to mind because it's salient, the current market return, and works through memory. Second, if I ask you to forecast the return for the future, you can control or predict that with the actual return of the investor or with the recalled return of the investor. The actual return in isolation predicts expectations, but the recalled return is what really matters. So we don't recall everything or everything perfectly, and what we recall, it's really what shapes our beliefs about the future. There are many implications from this. One is, we've investigated in the COVID paper in which we have a model and structure in which we think about this endogenous recall of experiences to think about new risks. You have COVID, but you have AI, you have robotics, you have war, you have phenomena that have not occurred before. Society needs to make decisions about these phenomena. How do people form beliefs in these cases? And like the endogenous record of processing of experiences is important there. And you can do that with beliefs data, with memory data, with recall data. Expectations, neither rational nor adaptive. These are selective memory retrieved on cues. Today you see high inflation. You know, to someone who's gone through the 70s, that's a very strong cue. So that person might react a lot. This person is not rigid in the expectations because he maps that to a specific experience. The elderly, the young, have not lived through that experience. So they might be rigid and underreact to the change. So again, it's not like mechanical experience, but it's reminders that create this instability. Advertising. Advertising, it's repetition about products that you know all too well, that you've consumed many times. It's a reminder, it's a cue. And it creates salient feature. You can become the top producer of a standard brand like cigarettes, tobacco, with the Marlboro Man. And then there is policy, nudges. Now it's like pretty vague. We try something and see if it works. But you can actually try to study these things by measuring what people think about, what they recall, the experiences they have, and so what's the right information treatment. And there is interesting research on that. To conclude, growing data urges us to rethink about foundations. Beliefs are central, and their instability is central. Instability does not mean Pandora's box, opening it. You know, heterogeneity doesn't mean that. There's a lot of structure out there. Can be discovered with new theory and systematic measurement that is now available. And this, I argue, it's highly relevant for understanding important problems in the economy, the behavior of people and markets.
We have time for some questions. Questions, please. Please.
Yeah, with respect to measuring attention, there's the technology of eye tracking. I'd be very curious to know what your thoughts are on this, and if you've thought about using eye tracking, and if not, then why?
If I can repeat the question, whether attention can be measured with eye tracking, so you put a device rather than with direct elicitations. Now, eye tracking, okay, it's a good technology. I think it's useful. The problem of eye tracking is that it captures a very specific form of attention that is visual attention, what you are staring at. Now, that is not obvious. That is what's most important for my decision. For instance, I could see two lotteries and decide on the basis of their payoff that one is clearly much better than the other. But I must spend a lot of time like distinguishing small differences in probability. I would be kind of, you know, spending a lot of visual time there, but that's not the main driver of my decision. So I think eye tracking, it's useful, but I think it's important also to measure higher levels of attention.
So you were very careful of not claiming that people are irrational, but it seemed that the implicit message was a bit like, look, you know, people make these weird decisions, they have these weird beliefs that we cannot explain. I mean, you didn't say it as bluntly, right? But I was wondering, how do you position your work and your perspective with respect to what is currently the dominant perspective in cognitive science, which focuses on the Bayesian mind, and that involves multi-level models where, for example, for some of these mistakes that you explain, they could be rationalized by assuming that people make an abstraction, that they have a higher level construct, and that is what could be seen as a memory leakage or imperfect memory could be rationalized, because when I see a lot of blue words, right, I might think of the generating mechanism that produces the proportion of blue words and orange words, right, and that there is a common mechanism generating these two proportions, right? So obviously we don't see these multi-level processes that people engage in when they make these inferences, but it could be that what appears as being mistakes or puzzles can be the result of our participants being a bit smarter than we are, right? Or than we assume, in the sense that it's very rare that in naturally occurring environment things are completely independent, and they might be thinking about these higher level generating processes. So is this, when you say proposing a new perspective on these mistakes or these beliefs, is this the kind of model you have in mind? Or are you aware of this type of work, or do you position yourself to that?
Of course, I am aware of this type of work. This type of work has a very different motivation and is of a very different nature of the type of work that I'm proposing here, okay? I don't dispute that from an evolutionary standpoint, we are equipped with marvelous machines, and that, you know, there are lapses in our behavior because we are not perfect, which means that, you know, even though over long time scales, these are served us perfectly in specific decisions, you know, because of this general purpose technology, you know, our immanent decisions, you know, may be led astray. So I don't want to run into a discussion, is this ultimately optimal or not? I think it is ultimately optimal. What I want to say is that relative to the standard benchmark, okay, in which the type of approach we have to decision making is that there are stable preferences and rational beliefs. There is a lot of progress to be made, and there is a lot in terms of explanatory power to be gained by introducing, not by having, you know, many biases floating around, but by taking empirical regularities in attention and in memory. These are out there, and I'm not disputing their origins, but by taking these regularities, including them in models of decision making, and then measuring the relevant inputs. That is what I'm saying.
More questions? Jordi?
Apologize in advance for the somewhat Philistine question, but shouldn't we be able to make some money out of all this?
Well, it's not so obvious, Jordi, no? Because, you know, suppose that you were an investor in 99 and 98 thinking that the market was a little crazy on dot-com stocks, okay? You know, as an investor in that world, in order to go against the market and the rising stock prices of the internet companies, you would have run a fairly significant risk. If you have limited budget because you don't have, you know, indefinite wealth, you may have run out of money early by taking a contrarian position, just because you don't know where the euphoria would stop. And, you know, the history is full of investors that maybe had a good judgment that the market was overvalued in certain parts, but that they lost and they were burnt because they did the, you know, contrarian strategy too early. So what I'm saying is that a lot of this, insofar as it's reflected in mispricing, does not mean pure arbitrage with zero risk. There's always risk involved, including the risk that, you know, expectations get even crazier in the short run.
Nicola, first of all, thanks for a great presentation. I just want to ask one little question. At some point you even said that beliefs are not rational and not adaptive. And I was thinking, what's the role of training or education? If you take enough statistics courses, you're going to solve the ball and earns, and you're going to solve the taxi cab, and so on. Is education a way of telling us what aspects should we take, even if they are not salient, or to correct some of these things? And how do you plan to expand your theory, or how have you worked on the issue of training and education?
Yeah, that's a great question. Now, the balls and urns and taxi cab puzzles, as well as many other puzzles, when they were originally proposed at the end of the 60s, you know, initially the experiments were with college students, with undergraduates, and then one of the objections was, well, but these are highly non-sophisticated. What if you try with sophisticated? And, you know, at Tversky, what does it stand for then? You know, they tried with statistics, PhDs, etc. And yes, it got attenuated, but some of these biases remained there. And why did they remain there? I think the reason they remain there, and I think addresses your point of education, is that educating someone is different from creating useful or used knowledge in any situation. You have a big library here, but in order to correctly solve a problem, you need to be able to retrieve appropriately what you have learned in order to solve that problem and understand that is relevant. And I think that if you look at many financial education programs, for instance, there are many experiments, a big literature on that, on financial education, helping people learn how to compute compound interest and things like that. You see short-run effect, very hard to find long-run effect, because, you know, of course, if you're a trader in Wall Street, you're good at harnessing those techniques. You immediately recognize the problem. But if you've gone through a course, maybe you will not remember this method or this piece of information when you are actually born to solve that same problem that you saw, say, a year ago. And this is, in psychology, very heavily studies, the psychology of problem solving, that, you know, you can make small changes to the way a problem is presented or to the mechanics of the problem, and people fail to retrieve information that was given to them before. So, you know, it is certainly possible that education can close part of the gap, and we know human capital is important, so it has to be true to some extent, but, and it's an interesting problem to understand. I don't know whether these things can be entirely dissipated, or what's even the power of education at the scales at which education can be actually implemented in the world, given all the many decisions that we need to make.
Any more questions? Yes.
Okay, maybe I would do a naive question. If I understand, Bernid's is unstable, but is aimed to predict economic behavior. But you showed that Bernid's are very dependent on background variables of whether you make attention or whether you had COVID or not. So my naive question is saying, beliefs or a stable utility, I'm on the statistics background, so I would say if belief is endogenous, and this endogeneity has to be explained by characteristic of the individuals, shouldn't we go back then maybe to utility or to more classic? I'm just wondering how beliefs can explain when it's such unstable that in the computations you show it, you aggregate it because you erase the measurement error, which is at the individual level, that would be the real threat. And if you want believer individuals to explain, you are asking questions, but the questions have measurement error. So I wonder whether that can have some sense from my statistics more
Yes.
perspective.
Yeah, it's a very good point. I think I like the word belief because I think belief conveys the idea of something that can be vacillating, that can be unstable. I don't think there is a clear distinction between beliefs and what we typically call preference or utility. You know, there is a psychophysics, or when I eat an ice cream, what are the sensations that reach my sensory organs and then the cognitive apparatus. That's an immanent thing. But when I decide whether to buy an ice cream or not, I have to sample information about ice creams that I had in the past, which kind of, do I like pineapple, strawberry, etc. tastes I like, and I have to make a guess. In that sense, I see beliefs as central in thinking also about decisions that we would typically argue involve utility, because they require an internal sampling. And this sampling is shaped by partly the experience we had. If I had a terrible pineapple ice cream, I will never eat again pineapple ice cream. But it might also depend on things that vary. If the strawberry ice cream is displayed with a very big and salient strawberry, maybe I really feel enticed to buy it. So we construct our opinions in this way. And I think from that perspective, preferences and beliefs are actually quite similar.
Okay, any more questions? Please.
So today you talk about two building pillars from which we can accommodate, we can provide a unifying theory of the belief biases. But it would be what I would call the updating biases. But there are other biases that are more about priors, like sample size neglect or the gambler's fallacy. So what are the pillars that you think we could build a unifying theory for all of this experimental evidence that is widely available?
I don't think there's a distinction between priors. When you start from memory, if memory is limited, is not prior something that is out there in a part of your brain and that you retrieve it. You have to construct it. So when you think about COVID, is that a prior or it's a posterior?
Well, I had in mind that, for instance, if I showed people a sequence of throws from a coin, a fair coin, and I throw one that had 5 heads and one that had 4 heads and then a tail, people tend to think the 4 heads and a tail is more likely than the other one. So I'm not sure how I can relate memory to accommodate this.
We have a theory of that in one of the 2 crazy COVID papers, which is precisely building on the idea of attention, and the idea is that this is a famous experiment. I mean, this is a famous phenomenon that was initially conjectured by Laplace, who said people will tend to think that if you throw a coin, a fair coin 10 times, it's more likely that it comes out balanced head and tails than all heads or all tails. Okay, despite the draws being IID and so not making actually a difference. I mean, of a specific sequence. Okay, head, tail, head, tail, head, tail. Yes. Thank you, Fernando. I saw your skeptical look. Was a very salient signal. Yes, okay? And so Laplace had made that conjecture, which has been shown to be correct with experiment. And there, the way we think about it is, again, attention. There is a feature of a string of flips. which is whether it's balanced or not. Okay? And if you pay attention to that feature, then you are going to answer a different question. You see head, tail, and you do not ask yourself, is this a specific head-tail sequence coming out, but is a balance sequence comes out? Because you think about that feature, the share of heads, because that is what you use to represent the problem. You replace the original question with a different question, and so you make that mistake.
Okay. So let me ask a question. So for the earns versus taxi cabs problems, I mean, do you think that we will get to a point, or maybe you are already there, that if I present to you a third or fourth representation of the problem, and I cannot think of a good example now, but imagine one involving something very unfamiliar from Vietnam and something from here, do you think that you will be able to predict which way the distribution is going to move?
So we have done experiments which do not involve experiences, in which we actually take a ball and earn problem and turn the distribution into cabs. Okay? And that's the way in which we describe the signal, that we do not say earn A has 80% green and 20% blue ball, and earn B has 20% green and 80% blue ball, but we say we did this process 100 times with replacement, and 80% of the time the color of the ball was the same as the color of the urn. So we focused your attention on the similarity between the ball and the urn, and that generates in the balls and urn experiment the exact same distribution that you have in the taxi cab. And we show that measure attention moves exactly the same way. So there are ways of making features prominent, in this case the similarity, that what we have not exploited, but this is, you know, this is really something that we want to do going forward. And I think it's very important what you just said, is to think about experiences, you know, because the way in real world you represent a problem depends on similar problems you've seen before. And so I could cast the same statistical problem in a format that causes you to attend to one statistic rather than another, thus generating predictable changes in the distribution of answers through recalled experiences.
So you think we are there? That you could?
Well, we are trying. I don't know if we will manage to do that, but we will certainly try in the next coming year.
Any other questions, please?
So combining that question with Jordi's question, given that you know, we as a species have an idea of how to manipulate decision making, is it the case that you know, competitive manipulation gets you to the right answer? Does it just get you to more confusion than ever, or is it, you know, whoever manipulates you last wins?
It's an interesting question. You know, I wrote a paper called The Competition of Attention, in which we study some of this. Rani Spiegler has been working on competition among narratives. You know, you see in politics, you know, advocacy, what do lawyers do? They try to emphasize certain features and pieces of evidence and to de-emphasize others. I don't know. I don't know what to say about this problem. I haven't thought about it enough. I think it's very interesting, and yeah, I think it's important, and probably it's worthy of study in the future.
Any other questions?
Thanks for the talk. My question is, so salience in this talk and in general is considered to be kind of exogenous. So there is something salient in the environment and we tend to focus on that, and then we go to selective recall, right? Now my question is, how much is it studied and understood about the opposite path? Kind of, I have something in my memory and then this shapes endogenous salience in some way.
Now, this is exactly what Jordi asked. That's important. But salience is not only that. You know, we formalize the contrast principle that it's important, that gives to a prediction that we show in balls and nerds and also goes to the change in the distribution. The contrast principle means that if some piece of information is striking, it attracts attention. You see a price difference among two goods that's enormous, it attracts attention. If you take a balls and urn problem and you increase the inequality in the color composition of the urns, we've done that experiment, you see that the mode on the likelihood increases. That feature, the composition, becomes more salient, it's more contrasting, and so you see a predictable shift in the distribution. So there's a lot also of measurability there and discipline that you put on your predictions.
Okay, thanks very much, Nicola. We have to leave it here and we move on to, I think there's a small reception. So thanks very much for a great lecture.
Thank you, thank you.